Hey guys, Mr. Roden here. Sorry I am not available to you in person today. Well, I am. I'm here, but I'm watching Mr. Sansoni's class also second period. So I just figured it would be easier just to have you guys watch the video and then start your homework. Now, I will say this in Delta Math. Let me click on it really quick. The Delta Math assignment is, let's see what the name of the assignment. Let me make this a little bigger. So the Delta Math assignment is called Slopes and Equations of Parallel Lines. And I just want to go over each one of these problems and just show you. And the due date on this is going to be the 27th. So the 27th is a Wednesday. So I'm giving you a few more days because it's kind of beefy. But you probably should get it done today or if you have time, or just get it done as soon as you can. So let me just go over these problems with you really quick and show you how to do some of them. All right. Now, the first one's pretty easy. It just says graph the line that is parallel to the given line. Graph a line that is parallel to the given line. Determine the slope of the given line that you graphed in simplest form. Then click and drag. Okay, so I don't. This is just copied into my OneNote, so I can't click and drag. So if you want, the first thing you need to do is figure out your slope, right? So you always want to find two really good points on your line, and this one is got lots of them. So looks like we have a nice point here, and looks like we have a nice point, I don't know, here. Looks like our slope is 1, right? Because we rise 1, run 1, rise 1, run 1, rise 1, run 1. So perfect. So you just want to click on a point wherever. I'll just go down here, and then you just rise 1, run 1, rise 1, run 1, rise 1, run 1. And then it's going to want you to just click and drag. You just click, and then I'm freehanding it. Sorry, not very good here. All right, and so you just click on one point, hold your clicker down, and then drag your line until you have a line parallel. And pretty simple. We learned yesterday that parallel lines have equal slopes. So the original slope was 1 in simplest form, and the parallel slope is 1 in simplest form. One other thing, guys, if you have a vertical line, this is kind of a review because it looks like you can have a vertical line. Remember, a vertical line is undefined, okay? Undefined. Okay? All right, so now, next thing I want to talk about is this next problem. So this is where we get into having some pretty good fun here. So it says, which equation represents a line parallel to this? Now remember, guys, parallel lines have equal slopes. So this line right here has a slope of negative 4/5. So m equals negative 4/5. Now the announcement's going to come on here a second. I'll pause it. So we want to, each one of those equations we want to look at and say, okay, which one of these equations is going to have a slope of negative 4/5? Well, they're not in slope-intercept form. So what I'm going to do is I'm going to put them in slope-intercept form. So I have 5x plus 4y equals 32. So let's put this one in slope-intercept form and see if it happens. I'll have to pause really quick when Mr. Joyner comes on the announcements. So I'm going to subtract 5x from both sides, okay? And then so I get 4y equals negative 5x plus 32. I divide everything by 4, and so I get y equals negative 5/4 x plus 32 divided by 4 is 8, right? So does this have a slope of negative 5/4? No. So this one right here, you don't have to put an x through it, but I'll just put an x through it because we'll have it, okay? So that one is no. And I'm just going to stop when I find the one. So I'm just randomly choosing them. So the first one was a no. I wish it was a yes, but it's not. So the second one is 4x plus 5y equals 25. And so we'll go ahead and pause the video
Good
really
morning,
quick.
Jenkins Jaguars. Please stand for the Pledge of Allegiance.
All right, so let's try this next one. Announcements are over. So we'll subtract 4x's from both sides, So we get 5y equals negative 4x plus 25. We'll divide everything by 5. So we get y equals negative 4/5 x plus 5, right? So does this have a slope of negative 4/5 x? Yes, it does. It does. So we are going to say it's that one right there because you don't care about the y-intercept. You only care about the slope, the m. Remember, just really quick, I know this maybe I'm overkilling this, but y equals mx plus b, where m is your slope. Okay? All right, guys, hope that helped. All right, let's go ahead and talk about, let's do another one really quick. So I don't think we need to do another one. If you just raise your hand if you have questions on this. So don't worry about this. A shortcut when I would look at this, just looking at this, well, I would want something with a 2 with the x. Well, anyways, don't worry, just ignore what I said. Don't worry about this one because just look at that last one. Sorry. All right, let's take a look at this one. Which represents perpendicular? Okay, so we haven't talked about this. Technically, we should prove this, but here's a key, and put this in your note. Perpendicular, first of all, means they form a right angle, right? So if we're talking about perpendicular, we're talking about two lines that form a right angle. And we just talked about that with Descartes and his coordinate plane. Those two lines are perpendicular. Now, when we have perpendicular, we're going to put a little right angle to show those are perpendicular, and we've talked about that. Now, wouldn't it be nice if we didn't have to say the word perpendicular all the time? Wouldn't it be nice if we had a nice symbol? So the symbol for perpendicular, and I'm expecting you guys to know this, the symbol for perpendicular is an upside down capital T. An upside down capital T, okay? So an upside down capital T is the symbol for perpendicular. So we want an equation that has what's the equation? Which equation represents a line perpendicular x equals 0? Okay, so what does x equals 0 look like? Well, x equals 0, if I graph on the coordinate plane, let me go back here. If I graph on the coordinate plane right here, the line x equals 0 is this line right here. It's basically the line x equals 0 is the y-axis, okay? It's the y-axis. It's this line right here. X equals 0 is the y-axis, okay? So this is x equals 0. That's the y-axis. So what is perpendicular to the line y equals 0? Well, it's going to be a horizontal line, okay? It's got to be a horizontal line. Any of these horizontal lines, like this one and this one and this one, even the y-axis, all of these lines, if I draw them correctly, all of these lines are perpendicular to the line x equals 0 because the line x equals 0 happens to be the y-axis. Okay, so which one of these equations is equal could be written as one of these red lines? Well, those equations are always going to say y equals just a number without an x. Those are all just what we call constant functions. Okay, so these are all, a constant equation is horizontal. So like a horizontal line could be y equals 7 or y equals 9 or y equals -2. So do we have an equation that looks like that? And yeah, we do. It's this one right here. So that equation right there is going to be a horizontal line because it has a slope of 0. X equals 0 has a slope undefined. Y equals -6 has a slope of 0 if you learned from last year's class. That's the way that's going to look. And guys, please ask questions if you have any questions on this, okay? All right. The lines represented by the equation. Oh, now one other thing I want to say before we were talking about perpendicular. So here's a fact, and write this down. Here's a fact about perpendicular slopes. Fact about perpendicular, there's my symbol, slopes. Okay, so the fact about perpendicular slopes, we'll put it in a conditional statement. If two lines are perpendicular, then their slopes are opposite inverses of each other. Okay? So, and I think we've talked about that this year, but if you don't understand what I'm saying, so let's say we have one line that has a slope of 2/3. Okay? Well, the perpendicular slope would be -3/2. See that? Okay? Let's say we had a slope of m equals -1/2. The perpendicular slope of that would be +2 or +2/1. So we flip it and change the sign. So that's the way you can think of perpendicular slopes. Flip it and change the sign. So perpendicular slopes are flip and change the sign. Parallel slopes are exactly equal. So let's go ahead and let me erase all this stuff here. And let's go ahead and use that fact to look at this problem right here. And these are all examples of your delta math, so this would be good practice. Okay, the lines represented by these two equations. Okay, so this one has a slope of -6/5. So one of the slopes is -6/5. Now the other one I have to solve for y here. So if I have y plus 6/5x equals -3. So what I'll do is I'll subtract 6/5 from both sides. So I get y equals -6/5x minus 3. I just put it in slope-intercept form. Okay, so look what we have here. We have this slope of the original one is -6/5. When we did our other one, this one right here, it also has a slope of -6/5. So what do we know about slopes that have the same? Now, one other thing I want to talk about is, so what happens? These slopes are the same, but they have different y-intercepts. This one has a y-intercept of 3, and this one has a y-intercept of -3. So let me say that again. These two lines have the same slope, but different y-intercepts, okay? So they're parallel because they have the same slope, but they're not the same line because they have different y-intercepts. Let me say that again. They're parallel because they have the same slopes, but they're not the same line because they have different y-intercepts. So the answer here would be parallel. If they had the same y-intercepts and the same slope, then they would just be the same line. So that's kind of some different options you could choose from there. All right, what's next here? Okay, another one of these. So this one, we need to put both of them in slope-intercept. So to be a little more neat and organized, I'll make this one my red equation, and I'll make this one my blue equation, and we'll take a look at them. Okay, so let's look at the red equation first. So it's y plus 3/2x equals -6. And so I'm going to put it in slope-intercept form by subtracting 3/2x from both sides. So I get y equals -3/2x minus 6. So that's the red equation in slope-intercept form. Now let's go ahead and do the blue equation. Well, the blue equation is 3y minus 2x equals -24. Okay, so the first thing I'm going to do is I'm going to move the 2x over, the -2x, by adding 2x to both sides. So when I add 2x's to both sides, I get 3y equals, I'll just put a little baby plus 2x on both sides to show you what I'm doing. I get 3y, the 2x's cancel, equals 2x minus 24. Now after that, I've got to divide by 3. So I've got to divide this one by 3, I've got to divide this one by 3, and I've got to divide this one by 3. So what do I get? I get y equals 2/3 x minus 24 divided by 3 is 8, right? So this is minus 8. So here's our two equations. I've got the blue equation and I've got the red equation. Now notice right off the bat, I'm noticing that their slopes are not equal. So they're not parallel and they're not the same line. But I do notice this one has a slope of -3/2 and this one has a slope of +2/3. So what do I notice about that? Yeah, those are opposite reciprocals of each other, or opposite inverses of each other, or a flip and a sign change is another way to look at it. So they are perpendicular, because that's our rule with perpendicular. Okay? All right, let's keep going here. All right, what do we have here? Okay, so this next one says write an equation of a line that passes through the point -2, -4, and is parallel to this equation. Well, the first thing I'm going to do is I'm going to go ahead, I'm going to write that equation down, and I just need to get its slope. I just need to kind of just um, steal its slope. And once I steal its slope, I'm just going to completely throw that red equation away. So to get its slope, I need to put it in slope-intercept form. So now I'm going to subtract 5x's from the left, and I'm going to subtract 5x's from the right. That gives me -2y equals -5x plus the 6 that was already there. Okay? So then I'm going to divide everything by -2, everything by -2, everything by -2. So now I get y equals, because these -2's cancel out to 1, equals a negative divided by a negative is a positive. And notice I'm going to leave it as an improper fraction, so that's positive 5 over 2x. And a positive divided by a negative is a negative. So that's going to be -3. So I have y equals 5x, 5 halves x minus 3. Now remember, guys, I only want this slope. I don't care about anything else. So I'm going to steal this slope, and I'm going to throw the rest of the equation away. So I know my new, and I want an equation that is parallel. Okay, so parallel lines have equal slopes. So my new line, I'll do it in black right here. My new line is going to have a slope of 5 over 2. Now, what I'm going to do now is I'm going to use this special point right here, and I'm going to solve for my b, because remember, every linear equation is in the form y equals mx plus b. Okay, so let's do that. So instead of a y, I'm temporarily, remember this is an x value and this is a y value, I'm temporarily going to replace my y value with -4 equals m. What's your m? M is 5 over 2. Your x is -2 over 1. And you do not know your b, so we're going to say plus b. All right, so now let's do the math here. So we have -4 equals, now I like to reduce before I multiply, so let me just reduce these. So 2 goes into itself once, and 2 goes into -2 -1 times. You could also just multiply 5 times -2, 2 times 1, and then reduce. It doesn't matter. I like to reduce before I multiply. It's just my preference. So 5 times -1 is -5. 1 times 1 is 1, so this is going to give me a -5 plus b. Hopefully I did my math right. All right, this is not good. No, get that popped away. All right, now the next thing I'm going to do is I'm going to solve for b by adding 5 to both sides. So those cancel. So now I get b is equal to -4 plus 5 is 1. So there's my b. So I know what my m is. My m is 5 over 2 because it's equal, because it's parallel. X, so y equals 5 over 2x. And then my b, I figured out, was 1. Hopefully I didn't make any mistakes there. If I did, let me know. But hopefully the process is more important if I think I did my math right. But you never know. Mr. Roden sometimes makes mistakes. All right, let's see here. We got, I think, the last problem here, and then I'll let you guys start. Okay, so now this one is perpendicular. So first of all, just like we did before, we're going to take this equation, 2x plus 3y equals 18, and we're going to put it in slope-intercept form. And then we're going to steal its slope, and then but it's perpendicular, so we got to tweak the slope a little bit, right? All right, so the first thing I'm going to do is I'm going to subtract 2x's from both sides because I'm putting it in slope-intercept form. So I get 3y equals -2x plus 18. Okay, after that, I'm going to divide everything by 3, everything by 3, everything by 3. So now I get y equals -2/3 x plus, what's 18 divided by 3? 3 times 6 is 18, right? So that's 6. All right. So now what I'm going to do now is I'm going to steal this slope. Now, remember, the key here is it's perpendicular, not parallel, perpendicular. So the key, so if my slope is negative 2/3, the perpendicular slope is going to be flip it and change the sign. So I'm going to flip it and say 3/2, and since it's negative, I'm going to change it to a positive. So there's my slope I want to use of my new line. So I'm just going to go back over here. And then I'm going to go y equals mx plus b. Remember, we're talking about the perpendicular line now. And so now I'm going to temporarily replace x and y with 6 and 1 and solve for b. So instead of a y, I'm going to put in a 1 equals, instead of an m, my perpendicular m is 3/2. Instead of an x, I'm going to put in a 6. And I'll call it 6/1. And then I'm still going to solve for b. Okay? So let's see here. So I like to simplify before I multiply my fractions. So 2 goes into itself once, and 2 goes into 6 3 times. Am I right there? All right. And then I multiply straight across. So let me go over here, switch to my pen color. So I multiply straight across, so I get 1 equals 3 times 3 is 9, 9/1 plus b. Then I solve for b. So I get 1 minus 9. 1 minus 9 is, 1 minus 9 is what? Negative 8, right? So b equals negative 8. So my new equation is, I've got my b, I've got my perpendicular slope. So my new equation is y equals 3/2x minus 8. And that's what you would want to put into Delta Math. Okay, guys, I'll be here. Just if you have any questions, let me know. Hope this video was helpful. Remember, then if you get done, you can just start your Delta Math. So have a wonderful day, guys, and we'll see you later. Bye.